The Glee2.net backend is structured in a way that works really well with domain-driven design, or DDD. If you've never heard of domain-driven design, I would encourage you to Google it and try to learn as much as you can about it, because we do try to stick to domain-driven design in a lot of our concepts throughout the Glee backend. Uh, Take a look here at this image of of some structure, and this will help us to understand a little bit more of how things are structured in the Glee backend. As you can see over on the left at the top, you can see the application layer. That is where, as you can see over on the right, the bullet list, that is where a lot of things are happening, like an API presentation layer, the web layer, things that are actually touching the client in some way are in the application layer. And the domain layer kind of sits in the middle of everything. The domain layer is, as you can see with the arrows, it's not depending on anything else. The other layers are depending on it, but it doesn't depend on anything else. And this is where you're going to have your domain entities, your interfaces, value objects, and a business logic, really. Everything that is business logic should live in the domain model layer, or we just call it the domain layer. And we do a lot of things, take a lot of pains in Glee to make sure that the domain layer is very clean and doesn't have a lot of extra things in it that are more like implementation details. We want to keep it clean. We want to keep it pristine, undefiled. And then down below, you've got the infrastructure layer, which is where a lot of times for most applications, you will have the database or the data layer is inside of the infrastructure layer. So that's where we're actually going to be going out to the database and actually be performing the queries and things like that. The application layer depends on the domain layer and the infrastructure layer. The infrastructure layer only depends on the domain layer. And we will see that here in just a moment when we look at our project structure in Glee. You notice here that the domain layer doesn't know that any other layer exists. The infrastructure layer doesn't know anything about the application layer. It doesn't know that it exists. The application layer knows about everything, though, because that's where everything has to get glued together and has to be presented to the client. So here in our structure, you'll see here under the Glee solution, you're going to see layers that mimic the layers from this image: application layer, domain layer, and infrastructure. Application, domain, infrastructure. So let's start with the domain layer. Open this up, and you're going to find, and as your project grows, this folder will also grow with all the different possible domain assemblies. Each one of these is an assembly or a project. You can see here that in our employee domain, we've got an employee root. We call this an aggregate root or an entity, and we've got its commands and events. Take a look at the common domain. This is just a place where we might be able to store things that are going to be reusable between all your different domain layers. You may end up with several different domain assemblies or projects as your project grows. Typically, it is a good idea to separate your domain projects by aggregate root. So you can see here this domain employees is all about the employee aggregate root. All of the commands have to do with that. All of the events have to do with that. And it all stems out of this employee aggregate root. And so you may end up with a project domain. And so there would ideally be a project aggregate root that is, it lives at the root of your domain.projects assembly. And you would have all the commands and events that have to do with that aggregate root, and so on and so forth. So you may end up with several of these different projects. They can know about each other in some ways. They should not know about the outside world. They should never have dependencies on anything outside of the domain layer. So as far as structure goes, this is how you would normally structure a one of these domain assemblies. You would need to have a commands folder. Inside that commands folder, you could have one or more validators per command. You would definitely need to have at least one handler per command, because if you try to dispatch a command and it doesn't have a matching handler, then it will throw an exception. On the other hand, with validators, if you dispatch a command and there is no validator for it, it'll just keep on moving. Inside of these folders, you can feel free to add more folders to provide more organization if it makes sense. We could have done it here in the handlers folder, but this is pretty manageable. We decided to go ahead and put a for create employee folder inside the validators folder just to help organize that a little bit better. However you decide to organize that is fine. And of course, all the commands are in the root of the commands folder. Events, very similar structure. All the events are right here in the root of the events folder. And then we have our actual event handlers in the handlers part of this. Now this is very true, having the event handlers here in the domain layer if the events have no communication with the outside world, which is often not the case. But depending on your project, you may have a situation where an event is event handler is running just on something internally, like you're updating a different another thing in another repository that still applies in the same place. So now you can also have event handlers in other assemblies. You could have an event handler in other layers, multiple opportunities. You can have an event handler in any layer at all. You can even have event handlers in complete other projects in other servers and the other side of the world. So the event handlers is the location of these is not as important as it is the events themselves. The events must be in this events folder. Now you can subfolder these if you'd like, if it helps to organize, but keep these events inside the event folder. These are the same events that are being thrown inside of our employee or generated inside of our employee entity. Here's one for employee event changed, and if you look here, there's not event change, address change, but here's the same event in the events folder. So this is how we are structuring currently our just one domain assembly for one aggregate root. If you end up with another aggregate root, then feel free to create a new project. These are just class libraries, so nothing special is needed inside of these class libraries, and structure your own domain assembly similar to this, and you'll be well on your way. I'll show you just a couple more things about the common library, the common assembly here. Here is our aggregate, which is allowing us to share this between multiple different domain assemblies. We also have its interface, and we've got a couple of entity files that may or may not. Sorry, this one is event, but this entity may or may not stick around. You may not see that when you actually come to the project. There are some domain level exceptions that may occur in your application, and they should be put here in this exceptions folder. The repositories here are only the interfaces, because the actual implementation of a repository is not a domain concern. It is more of an infrastructural concern. So we want to implement those repositories in the infrastructure layer, which we'll get to in just a few minutes. But as you can see, these are just the signatures of what we expect in these repositories. So if for some reason you need to add some sort of functions to the generic repositories, which would be really surprising. They're pretty complete as it is, but if you have to, you would want to add them here to these interfaces first, and then be able to implement them in the infrastructure layer later on. Same thing with services. Any kind of auxiliary services that you want to create that are not technology platform or infrastructure specific, you can add them here. This is an example of one, the identity generator. We want to be able to generate a GUID or some sort of identity using some implementation. But for right now, it's okay. It's enough just to have the abstraction so that we can code against that in the domain layer. The domain layer doesn't care exactly how it's generated. It only cares that it is generated. So that's what the purpose of this interface is. The implementation will be in another assembly in our infrastructure layer, which again we'll get to in just a minute. And here is this one just didn't have. There's no evident place to put this guy. It's just a base class that we can use to help to create validation classes. So if you remember back over here in our commands with validators, we've got this validate change employee name. It is inheriting from the command validator base, and it's just a way to try to reuse some code without having to have a lot of extra hoops to jump through every time we want to add a new validator. This is really all it's doing, is it's re-implementing this validate method. All right, well, that's enough about the domain layer for now, except well, I will mention one more thing, that the specs for these are usually named the same with a .specs at the end, and so that you can test these things out in a separate assembly. And when it's time to actually deploy these things to a production server, we can actually strip out the specs, and so that we're not deploying specs as well. But you can see here we are structuring the specs folders very similar to how we're structuring the actual project. We've got a commands folder just like up there, and there are no specs for events, but there is for entities. So this is something that you may want to put into a folder called entities or entity, or the employee entity. All of these tests have to do with the employee entity itself. Because it does have methods on it, they need to be tested. And there's nothing in the services folder, but if you were to write some tests around services, you could put them here. Basically, the idea is to keep things structured in a way that it's very understandable to future developers. So okay, I'll put that to rest just for now with the domain layer. Let's go into the infrastructure layer and see how things are implemented. So here we have two main assemblies, the data assembly and the services assembly. We'll take a look at services real quick. And here we can see one example of just the only service that we have currently. It may grow, but for now, and at the making of this video, we only have one, and it is the implementation of the identity generator specifically for GUIDs. So this is a GUID identity generator. And this is very simple. Its main job is just to generate a new GUID. The reason why this is important is because when we're doing unit tests, if we are using this static method in our production code, just out in the open, then it makes our unit tests extremely difficult or sometimes impossible to verify that things are working correctly. So we inject this identity generator into our classes, and then we can generate using that, and then we have the control we need in our tests again. So here's an example of the test that goes along with that service. So again, and I'm using test and spec kind of interchangeably, but again, it's going to be the name of the assembly dot specs, which is the structure that we need to be using. So then we have also the data assembly in our infrastructure layer. As you can see here, we are placing all of our migrations in the migrations folder. These are often automatically generated by Entity Framework. You may be hand coding these. Either way, they need to go into this migrations folder. In the repositories folder, we will find a couple of exceptions, and also, most importantly, the actual implementation of the read-only repository and the writable repository. So if you take a look at this, right off the bat in the constructor, you can see that the app data context, which is an entity framework thing, is actually being injected in here, which means to us that this is no longer a domain thing. It's an infrastructural thing. So we're not injecting an I anything. There's no way to extract this out, and it's getting into some very entity frameworkish things that like this detached and all that stuff. We don't want that in the domain. It belongs in the data assembly. So same thing with a writable repository. You can see that it is injecting things that are not domainish. So we're going to keep it here in the data layer and in the infrastructure layer. And of course, our entity framework app data context is right at home inside the infrastructure layer. If you look here, we'll take a look at the dependencies. The data project here, the data assembly, it only knows about domain employees. That's the only thing that it knows about as far as projects inside of this solution. You can take a look here in the services, and it's going to be the same. It only knows about the data. In fact, the domain layer, it only knows about domain common in this case. If you look back at the domain layer, domain employees, you can see here that it only knows about common. And even deeper, common doesn't know about any other projects in the same solution. So the deeper you go, the less things know about outside things. So this is really the way it should be. The domain assemblies shouldn't have any dependencies outside of the domain layer. So this dependency is okay. Other dependencies outside of the domain layer are not. In fact, the compiler will even not let you do it. It'll cause circular dependencies, and you won't even be able to add it as a dependency. So that's the infrastructure layer. And now we're going to look at the application layer, which holds a very familiar web project, WebAssembly. This is also another way to call this is our API. This is where we are actually interacting with the front end and providing endpoints to the front end. The web layer itself, or the web assembly itself, has an infrastructure folder, which is not to be confused with the infrastructure layer. The infrastructure folder is just an organizational scheme. It's just a place where we keep all of our bootstrapping and exception handling, things that have nothing to do with endpoints really, things that you shouldn't have to worry about on a daily basis, but things that do affect how the API works in its inner workings. So you'll see here that all of the bootstrapping tasks and extension methods are here in the bootstrapping folder. We've got quite a bit of exception handling going on in this exception handling folder. We've got one helper. As you add more helpers, if they're an infrastructural kind of like utility kind of thing, then you can add them here. And then our startup, of course, is something that is important here in our unit of work. Also happens to work with is inside the infrastructure folder so that it can wrap all of our requests in a transaction. We are structuring the web assembly right now with a folder per area. Now this might end up being the same thing as a folder per aggregate root or a folder per domain assembly, but it's only by coincidence. It's only by just it just makes sense in this case. It won't always make sense, but we do have an employee controller, and it looks like we've got two. I'm not sure exactly why, so I'm guessing this one right here maybe doesn't belong there, but I'll figure that out. So there is going to be one employee controller, and then also you're going to have the requests and responses that should be segregated into subfolders. And of course these requests and responses should be POCOs, where they don't have a lot of extra logic going on. It's just a property bag, a DTO, and that's how the employee folder is structured currently. with of course one snafu with two employee controllers. I'll fix that at some point. Same thing here, status. You've got a status folder that is basically holding the status controller and then all of its dependency, all of its things that it needs. So we've got this getter and we've got an interface. And you might be looking at this. Well, this is an interface. Why is it in the web project and not in the domain layer somewhere? So not all interfaces must be in the domain layer. Sometimes interfaces are very specific to that layer, and in this case, this is true as well. We want the injection of the API information getter to be testable, but we don't necessarily. It doesn't really belong in the domain layer because it doesn't have anything to do with the domain. It's API information. It has everything to do with the API and the web layer and the application layer. So that's why that's there. And of course you can see that there's the program CS, which is the starting point, the entry point for our application, and this is basically how everything is structured. If you are adding more areas to the application, then what you should do is add another folder and add the controller there with all of its responses and requests, and have that separated by folder so that it stays nice and organized. And as usual, you're going to see that we have tests separated by folders for the different areas inside of our web project in the web specs project. The last thing I want to show you is back in the infrastructure layer, we have one project that is kind of outside the norms. Now, normally we have something like with service.specs, it follows the convention of the name .specs. But in this case, we are doing something a little bit different, and this is because the tests that are inside of inside of this project, they are integration tests. There are very few good ways to try to do unit tests around repositories, at least the way we have structured them here. And we really want to be able to test how Entity Framework is really interacting. So we are using in-memory database, in-memory data context, maybe SQLite possibly. And so these tests are no longer unit tests. They are testing the repository, but then they're testing on down through the layers, trying to get all the way to a real database implementation so that we can see how that works. And many times with repositories and databases, this is the only way integration-wise to be able to test those things. So if you have integration tests of any kind, no matter what layer they're testing, hopefully it's in the infrastructure layer or the web layer or only, they should have the word integration with a capital I at the end. This is so that during the CI/CD process, we don't try to run the integration tests as part of the unit test suite. We can keep those separate. That concludes our demonstration of the structure of the Glee backend. Hope you enjoyed it. I hope you learned something.